Let's draw the Lewis diagram for the sulfur trifluoride anion. So again, we determine a number of valence electrons using the periodic table. So we have 6 for sulfur and 3 by 7 for fluorine. So that will be 27 valence electrons. And then we add an electron because we have a negative charge. And now we draw the skeletal geometry according to step 3 with the least electronegative atom in the middle. So in each bond 2 electrons are shared. So now we're left with 22 electrons. And then we complete the octet of the terminal atoms. So that leaves us with 4 valence electrons, which we now put on a central atom. And now we'll calculate the formal charge for each atom. So this assumes that the electrons are equally shared between the atoms in each bond. So a quick way we can do this is draw a circle around each atom and then subtract the assigned electrons from the number of valence electrons. So fluorine is a halogen, so it has 7 valence electrons, and then subtracting the assigned electrons gives a formal charge of 0. And that's the same for each fluorine atom. And sulfur has 6 valence electrons, and then we subtract the assigned electrons around sulfur, which gives a formal charge of -1, which is equal to the charge of the ion. So the formal charge around most atoms is 0, and therefore this is the most likely Lewis dot structure. And here sulfur has an expanded octet of more than 8 electrons. So for elements in period 3 and above, the additional electrons above 8 will fill the d orbitals.